Okay, thermodynamics. So the term thermodynamics means flow of heat, and it is derived from the Greek word thermos means heat and dynamics means flow. Our daily life we come across many useful reactions such as burning of fuel to produce heat energy, flow of electrons through circuit to produce electrical energy, metabolic reactions to produce the necessary energy for biological functions, and so on. Thermodynamics, it is the study of the transformation of energy. It explains all such processes quantitatively. What do you mean by quantitatively? How much of heat is transferred. Okay, அதுதான் amount தான் quantitative. It explains all such processes quantitatively and allows us to make useful predictions. Thermodynamics evaluate the macroscopic properties அப்படின்னா என்னது heat and work and their interrelationship. Macro na bigger. It deals with the properties of systems in equilibrium and is independent of any theories or properties of the individual molecules which constitute the system. So it is not dependent, it is an independent concept. Sorry, it is independent of any theories. The principles of thermodynamics are based on three laws of thermodynamics. The first two laws, first and the second law, summarizes the actual experience of interconversion of different forms of energy. இப்போ நம்ம நிறைய வாட்டி we have learnt mechanical energy is converted into chemical energy, chemical energy is converted into mechanical. Okay, so இந்த மாதிரி transformations பற்றிலாம் படிக்கிறது தான் என்னது thermodynamics. And the first two laws of thermodynamics, it summarizes the conversion of different forms of energy. The third law deals with the calculation of entropy and the unattainability of absolute zero Kelvin. So in the absolute zero Kelvin பற்றி you must have studied. எப்போ absolute zero வரும் அப்படின்னா ஜீரோ கெல்வினை தான் என்னன்னு சொல்லுவாங்க அப்சல்யூட் ஜீரோன்னு சொல்லுவாங்க. ஓகே, இப்போ 0 degree Celsius you must have learned this conversion in your lower class. 0 degree Celsiusனா 273 Kelvin. அப்போ 0 Kelvinனா minus 273 degree Celsius. நீ பார்த்துக்கோ, 0 டிகிரிக்கு உள்ள 0 டிகிரிக்கு 273 கெல்வின், ஆனால் 0 கெல்வின்க்கு minus 273, which this temperature is very difficult to attain. So அப்போ இந்த third law வந்து it has help us to calculate the entropy of the system. Okay, and the unattainability of absolute zero Kelvin apati, the third law will tell us. The law can be used to predict whether a particular reaction is feasible or not under the given set of conditions, but they cannot give the rate at which the reaction takes place. Okay, whether the reaction is feasible or not can be explained, but the speed of those reactions cannot be found out. So now we will get into the terms that are involved in thermodynamics. So used frequently, the terms used in thermodynamics, first is system and surrounding. இப்போ for example, Dufton Girls Higher Secondary School, இதில் I want to know about 11A. ஓகேவா, this is 11A. ஓகே, இதெல்லாம் வேறு பக்கத்து ரூமு, ரைட். ஐ வாண்ட் டு ஸ்டடி ஒன்லி அபவுட் 11A. அப்போ சிஸ்டம் என்னது 11A, சரௌண்டிங்ஸ் என்னது அந்த டஃப்டன் கேர்ள்ஸ் ஹை செகண்டரி ஸ்கூலில் அதர் தேன் 11A என்னென்ன இருக்குதோ அதெல்லாம் என்னது சரௌண்டிங். த சரௌண்டிங் இஸ் செப்பரேட்டட் ஃப்ரம் த சிஸ்டம் பை அன் இமேஜினரி வால். By an imaginary wall, or it can be a real wall also. அதுதான் வந்து என்னது பவுண்ட்ரி. இப்போ சும்மா ஒரு பீக்கர் எடுத்துக்கோங்க. ஓகே, beaker, water, beaker, water. So beaker is the system. Beaker குள்ள என்ன இருக்குது? Water. Water is the system. Beaker ஓட walls தான் என்னது? Boundary. Anything that comes out of that beaker is surroundings. Hope you can understand. System and surroundings. The universe is divided into two parts, the system and its surroundings. The system is the part of universe which is under thermodynamic consideration. Thermodynamic consideration. It is separated from the rest of the universe by real or imaginary boundaries. So you can see here, this is system, this is boundary, and this is surrounding. System, surroundings, and boundary. Example, the system may be water in a beaker, a balloon filled with air, an aqueous solution of glucose. On the basis of the physical and chemical properties, system can be divided into two types. Homogeneous system, heterogeneous system. இதெல்லாம் உங்களுக்கு எல்லாமே தெரியும். A system is called homogeneous if the physical state of all its constituents are same. Example, a mixture of gas, completely miscible mixture of liquids, etc. These are all in the same phase. Homogeneous. A system is called heterogeneous if physical state of all its constituents is not the same. Example, mixture of oil and water. So heterogeneous. Surrounding. Everything in the universe that is not a part of system, wall kuda irukkodadu, that is not part of the system is called surroundings. Then what is boundary? Anything which separates the system from its surrounding is called boundary. அதனால தான் அந்த எக்ஸாம்பிள் கொடுத்தேன், பீக்கர் எக்ஸாம்பிள். வாட்டர் வந்து சிஸ்டம், அதர் தேன் த திங் பீக்கர் அண்ட் வாட்டர் என்னென்ன இருக்கோ அதெல்லாம் வந்து என்னது? சரௌண்டிங். சரௌண்டிங்கையும் சிஸ்டமையும் பிரிக்கிறது என்னது? பவுண்ட்ரி. தட் இஸ் த பீக்கர் ஆஃப் த வால் ஆஃப் த பீக்கர். டைப்ஸ் ஆஃப் சிஸ்டம். இதுக்கு முன்னாடி என்ன படித்தோம் நம்ம? Two types of, on the basis of physical and chemical properties, two types of system, homogeneous and heterogeneous. அதுக்கப்புறம் system surrounding பார்த்தோம். இப்போ types of system. There are three major types of thermodynamic system: open system, closed system, isolated system. Open, closed, isolated. இப்போ ஓப்பனுக்கு வந்து சிம்பிள் எக்ஸாம்பிள், உங்கள் வீட்டில் வாட்டரை you are boiling, லிட்டு போடாமல் விட்டுடு, what happens? All the water will boil and go off. So content, a mass will change. இதே closed lid போடு, all the water will get evaporated on the lid. நீ ஓப்பன் பண்ணும்போது திருப்பியும் தண்ணி எங்கே விழும்? It will again fall into the vessel. Whereas isolatedனா, ஒரு ஃப்ளாஸ்க் எடுத்துக்கோ, ஃப்ளாஸ்கில் ஹாட் வாட்டருக்கு ஊற்றி வச்சோம் அப்படின்னா 12 hours வரைக்கும் அந்த ஹாட்னஸ் இருக்குது. அப்போனா என்னதுன்னா, it does not allow anybody to, anybodyனா another heat going out or coming in. Okay, no transfer of heat or anything matter that will not take place. So open system, closed system, isolated system. So a system which can exchange both matter energy which is surroundings is called open system. Hot water contained in an open beaker is an example for open system. In this system, both matter and energy is transferred to the surroundings. All living things and chemical reactions are open system because they exchange matter and energy with the surroundings. Next, closed system. A system which can exchange only energy but no matter surroundings is called closed system. Here the boundary is sealed but not insulated. Sealed na moodi irukku. Hot water contained in a closed beaker is an example for closed system. In this system, energy is transferred to the surroundings but not matter. So, but no matter can escape from this system. ஸோ சுடு தண்ணியை ஊற்றி வச்சுட்டு கொஞ்ச நேரம் கழித்து வந்து பார்த்தீங்க அப்படின்னா ஹீட் கம்மியாக இருக்கும். But still, if you open the lid, all the water vapor would have condensed, and again it would start to fall into the vessel. So in this system, energy is transferred to the surroundings, but no matter can escape from the system. A gas contained in a cylinder fitted with a piston constitute a closed system. Isolated system na, a system which can exchange neither matter nor energy with its surrounding is called isolated. Matter exchange panadu, energy exchange panadu. So simple example for that is a flask, thermos flask. Here boundary is sealed and insulated. Hot water contained in thermos flask is an example for isolated system. In this isolated system, both energy and matter neither enter nor leave the system. Properties of the system. Intensive properties and extensive properties. நிறுத்திக்கலாமா? Girls,